Welcome to the Math Record. Today we'll be learning about the properties of a polynomial. This video will be part 2 of chapter 2 in our Precalculus class. In our previous video, we introduced the idea of a polynomial. Now we're going to teach you how these equations work. The properties this video will cover are x and y intercepts, multiplicity, turning points, and end behavior. Let's start with the most common property that students are tested on, the x and y intercepts. In a graph, the x and y intercepts are any points that a polynomial crosses the x-axis. So it's these points right here. These points are often referred to as roots or as zeros, or as I said before, x-intercepts. Also, now furthermore, for y-intercepts, this would be the y-intercept where the line crosses the y-axis, hence the y-intercepts. Like for the x-axis, for the x-intercept, it will cross the x-axis. That's why it's called the x-intercept. There's y-intercepts are usually referred to as the initial point, or most commonly they're just usually called x-intercept. Y-intercepts. X-intercepts are interchangeable between roots and zeros. There's usually one y-intercept, and for x-intercepts, there's usually multiples of them. Or for x-intercepts, there's usually either one or more real of them, real x-intercepts, or roots, or they're gonna be imaginary. Let's move on to our next property. This will be multiplicity. Let's take, for example, y equals x minus 2 times x minus 5 squared and x minus 7 cubed. Multiplicity tells us it refers to the exponent that the root or zero, which is the x-intercept, is raised to. So in this case, what we will say is that since if we plug in x equals 2 into the equation, that means 2 minus 2 equals 0. Or we could plug in x equals 5 or x equals 7. So on the ones that can make zeros. So basically they're saying since this is 2, x minus 2 raised to the power of 1, it's going to be 2 the root of 2 is a multiplicity. Multiplicity. I might have miswrote it. 1. And for the 5, it will be the root of 5 is a multiplicity 2, and the root of 7 is a multiplicity 3. The root of, you see why? Because 2 is raised to a power of 1 right here, 5 is raised to a power of 2, and 7 is raised to a power of 3. The interesting about property about multiplicities is that, let me erase this first. Oh no, y equals x minus 2, x minus 5 squared, and x minus 7 cubed. The interesting about property about multiplicities is that if it's odd, if it has an odd multiplicity, then the line crosses the x-axis. Sorry. Really bad handwriting. And if it's even, the line bounces off the x-axis. So what does this mean? So basically, if it's odd, it's gonna be something like this. So we have a 2, right? So we have a 2, and then let's say a 5. And then we're gonna say, oops. So, this is, 3, 4, 5, 6. We're just, this is not gonna be the correct shape, but it's gonna be something like this, right? So, this is not the correct graph for this, but we're gonna take, for example, this, right? Let's say this point right here is 2. So if since it has an odd power, it's gonna cross the x-axis, the line, and since x minus 7 to the power 3 is also odd, so it's right here. It's also gonna cross the x-axis. But you see x equals 5 right here. It bounces off the graph, the x-axis. So that's what it means when it says the line bounces off the x-axis if it has an even multiplicity. So that's basically the graph for multiplicity. Now let's continue on to our third property, turning points. Turning points are basically like the curves in a polynomial. So let's just draw a random polynomial. So something like this, right? If you had turning points are like points right here, 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 and here. You see why, right? Because these are turning points. It's turning at the curve. So there's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. There's 6 turning points. What does turning points tell us is that if there's 6 turning points, that means there is the polynomial is at least degree 7. Because think about it this way. If you have a linear graph, right? It's like this, you have no curves, so there's 0. But the polynomial is actually degree 1. Right? And if you have a quadratic, 1 degree, I'll just write D. Actually, I will write on the bottom right here. 3. And if you have a quadratic, you only have 1 curve, right? 1 turning point. If there's 1 turning point, but the quadratic is actually 2 degrees because it's x to the power of 2. Right? You see how there's like the degree is equal to 1 plus the turning points. So that's what it is. If there is 6 turning points, that means that it's at least degree 7. Let me erase this. And the inverse is true. So if we have a polynomial like x to the power of 7, then there is at most 6 turning points. At most. Because sometimes there might not be some of these turning points. They might be kind of like inflections. What they'll look like is that it'll look like this. So, like that. But it's not really like turning. You see how it works? Because a turning point would be something like this. But this could be an inflection. So sometimes it's like that. Now let's move on to our fourth and final property, the end behavior of graphs. This tells us what the graph looks like in the end of like when when the value gets too positive or when the value gets too negative. So I'll give you a general picture to understand. So let's say we have a polynomial like this, right? As we approach like a really large positive, right? This number gets really positive. So we say the right end behavior is positive. And if you approach the left side, it becomes really negative, right? For the x value. And this thing is going really negative, so we say the left end behavior is negative. So that's the basic idea. Now, how does this apply to polynomials? Well, if you have a odd degree term, right? Let's say your polynomial is x to the power of 5, right? what it tells us that if it's odd, it's gonna have something like this, where it has become really that if the number becomes really negative, then the graph becomes really negative, so the left end behavior is negative. And if it approaches to a really positive number, then the right end behavior is positive. A good way to tell this is that, let's say x, right? You plug in like a really big positive, let's say like 1,000. Then 1,000 to a power of 5 is just a really big positive. It's just a really big positive. So the right end behavior is just positive. Now, if we plug in a number like negative 1,000, negative 1,000 to a power of 5 is just a really big negative. So we say the left end behavior is negative. Because as the number x becomes more negative, it gets even more negative. You know how that makes sense? Or if x is equal to 1,000, as it becomes higher than 1,000, it becomes even more positive. You see how end behavior works? And now that's only for odds. So let's do a case for evens. So we have f of x is equal to x to the power of 4. So a graph would look something like this. It's not the correct graph, but it will be something similar. So what it tells us is that x to the power of 4, that if x is really positive, then then the right end behavior becomes positive. But if x becomes really negative, then the left end behavior becomes really negative. This is the right end behavior because like this is the right side of the equation, and this is the left end behavior, which is the left side. Just to be like self-explanatory, but like you might just know why. So this would be how it works. So for odd polynomials, like if the highest term for a polynomial is odd, then there's always gonna be there's always gonna be one positive and one negative, like end behavior. And if it's even, they're both gonna be the same. They're either gonna be both positive or both negative. So how do you tell? Well, this is what you do. You just look at the coefficient of the highest term. So let's say you have an equation like x to the 5 plus x to the 4 minus x to the 3 minus x to the 2, like just whatever, right? You see the highest term in here, let's say it's 1, right? 1 is positive. So if 1 is positive and you have an odd, you have a positive odd. If it's positive and it's odd, then it's gonna be a negative in the left and a positive on the right. If it's a negative odd, like let's say the coefficient in top of this in front of negative x to the power 5, then you just switch it. So it just be a positive left and then negative right. Same game goes for evens. Let's say we didn't have this term, right? And we have x to the 4. Then we have a positive even. We have a positive left and a positive right, as I said before in my previous example. And you have a negative even, like if this was coefficients at -1, then we have a negative left and a negative right. So if you have a negative coefficient in front of when it was originally positive, you just switch the sign. So it's negative to positive, positive, negative. And in case for evens, they're both the same, which is positive, positive, then negative, negative. So this case always works. If it's a positive odd, it's a negative left and a positive right. If it's a negative odd, it's going to be a positive left and a negative right. If it's a positive even, it's a positive left and a positive right. And if it's a negative even, it's a negative left and a negative right. We really don't want to care what these terms are, because as this number becomes super big, then it's just not going to be affected by these like smaller numbers. So that's basically what it is for end behavior. You really don't need to like memorize that, because like the easier way is what I said is like, let's just say you plug in x is 1,000 for a really big positive. This will find you a right end behavior, because the right end behavior is when the x becomes really positive. And for a left end behavior, you put in x is like a negative 1,000. You really don't have to find the specific answer, but if you just think about it logically, like if it becomes really positive or really negative, then you could just find out what's going to be the end behavior for both these. This concept works for like basically any function, not just polynomials, but it works extremely well with polynomials because you only have to look at the first term. So if your highest term is x to the 6, just look for x to the 6. And you always just focus on the coefficient. Let's say the coefficient is a. Wait, let me erase this. We have a coefficient a and exponent b. You only have to look at the coefficient and you only have to look at the exponent. So you could determine which one's the right and left. Or if you memorize it that way. Or you could just use this way, which makes you just think about it. So if x is like 1,000 or x is negative 1,000, which gives you the right and left respective end behaviors. All these properties, x and y intercepts, multiplicity, turning points, and end behaviors just tell us how to plot these graphs and how they look. This would be the general concept that precalculus classes and our class will try to teach its students. Just try to teach them to like graph equations, not just polynomials, as precisely as possible, so you understand like how equations look. This teaches like students how to like understand patterns in equations and just to like make a really precise graph. See, that's basically what is the majority of precalculus. How to draw a really good graph and how to understand how these graphs works. Anyways, that is all for this video. Thanks for watching, and I'll see you at the next math record.